Okay, so I'm going to make a video over pH, explaining pH and explaining titration for those who are absent or who didn't quite get it in class. We've gone over pH and titration in class. We've even done a titration lab in class. But I feel like, I don't know, if you missed class, you really want to get this extra information about pH. So pH, you guys have been exposed to this in your past, the pH scale. You may already know what it looks like. It goes from 0 to 14 with neutral 7 being in the middle and 0 on this side being acidic and alkaline on the right, or basic, okay? So this should be familiar to you, neutral. And this should all be kind of known, all right? So this is known, and if you look in your notes, you'll notice that I mentioned a pOH scale, okay? Which is basically the same thing as this, except this and this are switch sides. So the pOH scale, okay, goes from 0 to 14 with neutral as 7. But on this side is alkaline for the bases, and on this side is for the acids. Okay, so we're not really going to focus on this one, more of this one when we talk about the pH scale, but I'm going to show you a couple of equations that will make sense only knowing that there is a pOH scale if you haven't heard of it. So there on your test, you're going to need, as far as the pH section of your test, you're going to need to know 4 equations, okay? 2 are almost identical, and then one is super easy, and the other is just kind of a constant that you need to know. All right, so the first equation that you need to know is when you calculate pH, okay? So you can calculate pH, and pH is based off of the concentration of hydrogen ions, okay? So pH, when you calculate pH, you're actually finding the negative log of the concentration of hydrogen ions. Okay, and what that means is every step down or up the pH scale, 7, 6, 5, 4, 3, 2, 1, 0, okay, every step down the scale 5, 4, 3, is a not just equally higher in hydrogen ions, okay, concentration. It's actually getting higher by a factor of 10. So for example, 6 will have 10 times more hydrogen ions than it's something with a pH of 7. And 5 will actually have 100 times more hydrogen ions than a pH of 7. And it keeps going up until a pH of 1, which will have, I believe, 1 million. So it's 1, 2, 3, 1, 2, 3. 1 million times more hydrogen ions than a pH of 7. So that's basically what it's saying here. So every time you move down or up the periodic table, the pH table, or the pH, pH scale, then you're going up or down by a factor of 10. And so if you know anything about logarithms, then you know that logarithm is basically a way to find out what, let's come down here since it's not that relevant. Let's say we have 10, actually let's not use 10. Let's say we have 2 to the power of 4, okay? That equals 2 times 2 times 2 times 2, okay? So that 2 to the power of 4 is equal to that. And a log is just, let's say we have 2, okay? We don't know what it's the power of, and let's say we know the answer here is 16, okay? So a log would be to find out what this number is, okay? Now, when we're in chemistry and we're talking about pH, we're going to assume all of the bases are 10, okay? So all of these are assumed to be 10, okay? So knowing that, let's say if we want to calculate pH, we would take the negative log and multiply it by, or the negative log of the concentration of hydrogen ions. Let's say we have pH, but not concentration of hydrogen ions. So we need to get this on the other side and have this by itself. So then manipulating this problem would give you 10 okay, and don't forget the negative, to the power of negative pH, okay, is equal to the concentration of hydrogen ions. If you wanted to manipulate this problem, okay, so these problems are just getting hydrogen ions by itself, and we'll do a couple of problems like that. So here's one you need to have memorized for your test. Another one equation, okay, is the pOH is equal to the negative log of the concentration of hydroxide ions. So this is assuming this scale right here, not this one, okay? So here's the second equation you need to know. And to manipulate it is the same thing, okay? So you would have 10 to the power of negative pOH is equal to the concentration of hydroxide ions if you wanted to manipulate it around, okay? Now, the third equation you're going to need to know for the test is the fact that pH plus pOH is equal to 14, okay? So whatever number you have plus the other number, the pH plus pOH equals 14. And it helps to know that there are two scales, okay, inverted. So technically, if this is the opposite of that one, if this plus this should equal 14. Moving on, the last equation you need to know is the ionization constant of water. And what that says is, so water acts as an acid or a base and dissociates into ions, rarely. And the ion dissociation constant of water is just the hydrogen ions, okay, times the hydroxide ions is equal to 1.0 times 10 to the negative 14. That's your last equation you need to know for the pH section of your test, okay? So you need to know those. Let me go up a little. Okay. So those are the 4 equations you're going to need to know for the test. Now, as far as some homework practice problems, we did some in class, but I would like to do a couple on here in case any of you are still stuck. Okay, so here, on the homework on number 1, first I want to show you that this actually goes up here, okay, and C starts here. And then all of this actually kind of go up here. So my bad, I'm sorry. This looks bad, okay? Either way, let's do 1A, okay? So we have a concentration of hydrogen and we need to know the pH. Okay, so we need to know pH and we have the concentration of hydrogen ions. So we're going to use the equation, this one, okay? We need pH, we have concentration of hydrogen, so let's just plug it in. So negative log of what they give us, 1.2 times 10 to the negative 2. And you just type that in your calculator, which okay, and what does that look like? Okay, so here's the typical calculator you can use on my test. If you bring a graphing calculator, I'm not allowing you to use it. For one, it's in the student handbook saying you can't use it. And for two, you can store data in it. That's not fair that you have access to and others don't. All right, so how you type that into the calculator, you type in negative sign. So find your negative sign. It's not the minus sign, okay? Negative is right here. So you type that in. Okay, so the negative log, and log is right here, so negative log, and it should open up a parentheses. If it doesn't, open one. And then you just type this number in. So 1.2 times 10, and I don't know how you do your exponents, okay? I do my exponents by, this is not the calculator that I use normally, so usually I have my little, what is it, that half triangle thing. Sorry, I don't know what it's called. But you can also use this if you want to use that. That means I'm going to delete it. So times shift 10 to the negative 2 power. And then push over to get it down because you have to close your parentheses. Okay? So there's a couple of ways you can do exponents. You can even use this one right here. Whoops. one right here. It doesn't really matter. They all work the same. Okay, so we have that in our calculator, and you just push enter or the answer. Sorry, I pushed the wrong button. So our answer here is 1.9 because we have two significant figures. So pH is equal to 1.9. So the question also asks to indicate whether the solution is acidic, basic, or neutral. So obviously there's a range of neutral, but if it's not 7, just assume it's the pH. If it's less than 7, assume it's acidic, and if it's more than 7, just assume basic. That way you don't have to worry about a range. So this is acidic, very acidic, like stomach acid's acidic, okay? So that's a pH of 1.9, and that's how you do the first one. So let's go to number 2 and look at a different problem. So basically it's wanting us to do the opposite of what we just did. They give us pH and they want us to find the concentration of hydrogen ions. So we're doing number A, letter A. So we have the pH. We're still going to use this equation, but since we have to manipulate it around, we're actually going to use this one, okay? So we have pH and negative log of the concentration of hydrogen ions. So we're trying to find this one, so we need to isolate this. So we need to get this negative log to the other side, and how you do that is 10 to the negative, the power of the negative pH, which is 2.5, is equal to the concentration of hydrogen ions. And these brackets, those brackets just mean concentration of, okay? That's what the brackets mean if you have not been in class for the last week or two. So in your calculator, all you would type in is, you could type in 10 to the power of, if you had that little, it looks like this, okay? That's what I usually use. This isn't my normal calculator. But today I will have to use the 10 to the exponent, which is negative 2.5. And my answer is 2 significant figures, so 3.2 times 10 to the negative 3 is my hydrogen ion concentration. Or you could call it molarity. Okay, so that's how you answer number 2. The number 3 and 4 are super easy. We're using the equation right here to find the answer. pH plus POH equals 14. So here we have the POH, so pH plus POH equals 14. Let's do it Dr. Christakis style so that we manipulate everything before we plug in numbers. So we want to isolate pH because that's what we're trying to find. So we're minusing POH on both sides. Okay, so then you have pH equals 14 minus POH. Now let's plug in our number. So pH equals 14 minus 4.18. I believe it's 9.82, but you guys know or 10.82. I don't know. You know I am not good at those kind of maths. 9.82. So the pH is equal to 9.82. Okay, and that is basic. Okay, so moving on, let's look at a problem that has like multiple steps to it. So let's look at number 8. I think would be a more difficult problem to solve. There we go. Number 8 would be a little more difficult. What is the pOH of a solution that has a concentration of hydrogen ions of this much? So we have concentration of hydrogen ions, and there are a couple of ways that you can go about doing this. It's okay if you found one route when I'm doing a different one. So you have concentration of hydrogen ions. So we could use this right here, this equation, to get the pH, okay? So then once we have the pH, we still need to find the pOH, and then we can use this equation to find the pOH. Another solution you could have done was take this and use this equation to find the concentration of hydroxide ions, and then you could use this equation to find the pOH. You could do either or. I'm actually going to do it this way, because we haven't used this equation yet, and that way you can see this equation in action. So we're going to convert not convert really, we're going to take the concentration of hydrogen ions and find the concentration of hydroxide ions, and then calculate the pOH from that. Okay, so first we're going to use the equation H plus OH minus is equal to 1.0 times 10 to the negative 14. So we have hydrogen ion concentration. So let's get the hydroxide ions isolated. Okay, so we have OH equals 1.0 times 10 to the negative 14 divided by the hydrogen ion concentration. So let's just plug it in now because I'm kind of not wanting to rewrite all of it again. And I'm sure you don't want to sit here and watch me rewrite it. And then we just plug it into the calculator. And if you want to do your whole in your brain subtract because of the dividing whatever, that's fine. I'm not the best at that. 1.0 times 10, oops, I forgot this is not the calculator. I need to do this. Times 10 to the negative 14 divided by 7.7 times 10 to the negative 7. Okay, and that equals 1.3 times 10 to the negative 8. So the concentration of hydroxide, wow, that's an H, hydroxide ions is 1.3 times 10 to the negative 8. But that's not what the question's asking for. It's asking for pOH, right? So now we can plug that into this equation, okay? We have the concentration of hydroxide ions now. We plug it in here. So pOH is equal to the negative log of, we just plug this number in, 1.3 times 10 to the negative 8. Then we calculate it, okay? So how you would do that, is you type in the negative log of 1.3 times 10 to the negative 8, close parentheses, and the pOH is equal to 7.9. And that's the answer.